Hello students. What we're going to do in this video is have a look at first the asymptotes for the equation y equals a on x, and then we're also going to have a look at the transformations of this particular formula. So let's start by looking at the simplest possible equation, simplest possible hyperbolic equation, y equals 1 on x, and this is the graph of it just here. So when x gets larger, for example, when x is equal to 5, y equals 1 over 5. So when x is 5, y is 1/5, which is that point just there. The bigger x gets, the closer this graph gets to the x-axis, but it never actually touches it. So therefore, the x-axis is the horizontal asymptote. Let's say that x equals a number like 1/5. Well, 1 divided by 1/5 is 5. So when x equals 1/5, y equals 5. So as x gets closer to 0, y gets larger and larger and larger. Once again, this graph will never actually touch the y-axis. So the vertical asymptote is the y-axis, or the equation of that, of course, is x equals 0. Similarly, if x equals -5, y becomes -1/5, which is that point. And if x equals -1/5, y becomes -5, which is that point. So every rectangular hyperbola has a horizontal and a vertical asymptote. Okay, let's see what happens to the graph as we change the value of a. And for that, we're going to use Desmos. Okay, so here we are in Desmos. So there's the equation, y equals a on x, where a is equal to 1. So that's the equation, or the graph, sorry, that we had before. Now, before I move that slider to 2, I'd like you to have a think about, pause the video and think what's going to happen to the graph when I make a equal to 2 or 5, etc. So let's see what does happen. I'm going to slide that up to 2. So the point that was there has moved up to 2. And the point that was there has moved down to -2. And if I change a to 4, the point that was at 1, 1, 1 is now at 1, 4. And the point that was at -1, -1 is now at -1, -4. So as you may have suspected or thought, the effect of a, basically a becomes the vertical dilation away from the x-axis. So the bigger a is, the more the graph moves up. That part of the graph moves up, and that part of the graph moves down. Okay, let's have a look at some other transformations. Okay, so here's the basic equation, a over x takes c, all plus d. So let's have a look at the effect of c and d on the hyperbola. So back to Desmos once again. So I'm going to move the c slider to the right 2 units. What do you think is going to happen to the graph? Well, let's try it and see. Well, if I can get it exactly at 2, there we go. So the point that was there has moved 2 across to the right. The asymptote, which was at x equals 0, is now at x equals 2. So the effect of making c larger, making c positive, is to move the graph to the right. And if c was negative, for example, at -2, then the point that was at 1, 1 is now at -1, 1. And similarly, the point that was at -1, -1 is now at -3, -1. So when c is negative, oops, better move it a bit further. This is hard to get it exactly on the spot. There we go. So the effect again of C, if C is positive, it moves the graph to the right. If C is negative, it moves the graph to the left. Let's put that back to 0. And what do you think is going to happen with the D? If I make D equal to 3, how's that going to affect the graph? And hopefully you thought that that basically is a vertical translation. So if D is equal to 3, the point that was at 1, 1 has moved up to 1, 4, etc. So D is a vertical translation up if it's positive. If D is negative, D is a vertical translation down, and that's exactly the same as what happens with all the other transformations of other functions that we've learned. So I think we'll stop just there. Oh no, I've got one more thing that I want to ask you. This is a bit of a challenge question. A lot of our transformations also have a b multiplied by x minus c. It turns out we don't need that for the rectangular hyperbola. So my question is, why not? Why don't we need to have a b in front of that? How can we get away without using it? So I'm not going to give you the answer right now, but that's just a bit of a challenge question. Just have a look at that equation there and see if you can figure out why we don't have to have a b for this particular transformation. And we'll stop the video at that point, and we'll get some practice at transformations in the next video.